Assalamualaikum Doctor and my fellow friends. My name is Nur Natasha binti Ahmad Fauzi. Today I will explain about gas chromatography. What is chromatography? Chromatography is an analytical technique that used to separate the chemical component of a sample mixture and then detect them to determine their presence or absence in sample. Then we go through the principle first. What is principle of chromatography? Chromatography principle is separation and analysis of volatile compounds or chemicals in a mixture. Gas chromatography is very commonly used in analytical method that we use in the lab. Although it uses gas as a mobile phase and then stationary phase, it is based on the fundamentals of chromatography. Okay, then I will explain about what is operation in gas chromatography. It works by injecting a sample into a gas stream, it carries the sample through a column when it's separated. The separated components are detected and will identified by gas chromatography machine. And there is 7 steps. First step is sample collection. Collect a sample using a syringe or the other methods. The second, the sample injection will inject into the sample into the gas chromatography sampling pot. The third, the sample will vaporize in an oven. Then the vaporized sample is carried through the column by an inert gas. Then the sample component will separated in the column. Then the sample will detect by detector at the column outlet in the machine. Then the final is the detector signal is recorded by a computer to create a chromatogram. The factor that affect the separation is when it's in the stationary phase, the column lining or filling, which the sample's component will interact with each other. Then the temperature column will affect how quickly the sample components will elute. And the vapor will pressure when the sample components separate based on their vapor pressure. Okay, now what application that we can use in the gas chromatography that we can use in the company or some the pharmaceuticals. The gas chromatography is used in pharmaceutical business to help create pure pharmaceuticals in big quantity. This technique is guarantee the materials purify and get rid of irregularities in pharmaceutical items such as like antibiotic and injection or vaccine also. It used in industry to analyze substance and look for traces some pollutants. This technique is currently being used more and more to distinguish chiral substance. It's to identify and measure chemicals that are released into the air inside the car from its carpets, door linings, pedals, seat and covers, and other interior materials. And scientists aim to reduce levels harmful toxins released. It also can be applied in the food analysis and quality control are the most common application for gas chromatography due to their component quantifications, accuracy and speedy process. Because with gas chromatography, fruit producers can accurately quantify the elements in their food, and the FDA ensures that it's okay is the sufficient quality and safety. Thanks to gas chromatography, consumers can purchase food at grocery store with confidence that it's been thoroughly tested for safety and that the food labels are accurate. Okay, here we do show you about the gas chromatography video, the explanation how the gas chromatography works. Okay, first we take the blood sample preparation by using syringe and put it into the vials, and we separate it into the two vials. Then put the some blood sample in the sample cup by using a pipette. The samples are generally dissolved or diluted in the solvent and then injected into the inlet pot. Some samples, such as essential oils, are not diluted. Other methods of sample preparation include sample such as essential oils are not diluted include sample introduction techniques such as thermal desorption and headspace. These are easy techniques for there is typically no or no minimal sample preparation. Then we mix the vials with internal standard preparation. This process is called ISTT. Then we take one of the blood sample vials and put into the auto sampler. Then the step 2 is the vaporization. This is as simple as it sounds. The liquid sample is vaporized in the hot inlet and become a gas. And the step 3 is the separate. Here's an inert gas such as helium carries the sample through the column. Different substances in the sample interact differently with the column stationary phase depending on their chemistry. This causes them to travel through the column at different speeds, thus separating them. Then the detection will the separated compounds then leaves the column one after the other and enter a detector such as mass spectrometer. The use of a mass detector is helpful because of the huge amount of organic compounds. At times, compounds may include at the same time. MS helps identify what the compound is and separate them by mass. This time taken for a compound to travel through the column is called its retention time. Then the chromatogram, the last step. The GC produces a graph called a chromatogram, which shows peaks the size of a peak indicates the amount of each component reaching the detector. The number of peaks shows the different compounds in the sample. The position of peak shows the retention time for each compound. Then, how does gas chromatography work? The sample will exchange most commonly from a liquid auto sampler. Then the step 2 through receptor, which enables the injection of the sample mixture without losing the mobile phase connected to the inlet, is the analytical column.
Gas chromatography or GC has so many advantages. The first one, there are high sensitivity and high accuracy. GC can detect and quantify compound at a very low concentration, making it ideal for trace analysis. The second one, they give rapid analysis. It provides fast results compared to other analytical techniques, especially when using optimized conditions. Next, they give high resolutions. GC separates complex mixtures into individual components with excellent resolutions, enabling detailed analysis for multi-component samples. The last one, they give wide applicability. It is suitable for broad range of volatile and semi-volatile compounds, including gases, liquids, and some thermally stable solids. However, there are some limitations using the gas chromatography. The first one, they are limited to volatile and thermally stable compounds. GC is primarily suitable for compounds that can be vaporized without decomposing. Non-volatile or thermally labeled substances are not easily analyzed. The second one, sample preparation requirement. Non-volatile or complex samples often require extensive preparation, which can be time-consuming and increase cost. Next, they can destructive analysis. Some detectors, such as flame ionization detectors, are destructive, meaning the sample cannot be recovered after analysis. The last one, they are time-consuming method development. Developing a GC method with optimal condition for separation and detection can require significant trial and error. Example or case study to illustrate the real-world application. The first one is using in environmental monitoring. For example, regulatory agencies monitor urban air for volatile organic compound VOCs contributing to pollution. Application GC coupled with mass spectrophotometry is employed to identify and quantify VOCs such as benzene and toluene. Next, in food and beverage industry. For example, a company analyzes the aromatic profile of different food products to ensure quality and consistency. Application GC is utilized to separate and identify volatile compound for flavor and aroma. The last one in pharmaceutical industry. For example, a pharmaceutical company tests raw materials and finished products for residue, solvent, and impurities. Application GC is employed to detect and quantify trace level of solvent and other impurities.